Hi all, today we are going to see a question from GATE 2017 Mechanical Paper 1, question number 40. So a point mass of 100 kg is dropped on a massless elastic bar. Okay, so it is dropped from some particular height and you are supposed to find that due to this impact of this particular mass, what is the maximum compression of the elastic bar. So before going into the problem, if you want to know more details about the axial deformations and all, please check out this particular strength of materials NPTEL course by Professor M.R. Shivakumar from IIT Madras. So let's go ahead with the problem. So due to the impact loading, there will be some elongation or compression. So basically any deformation happening on a body, and that can be expressed in this particular form. So let's see how to obtain this particular formula first. So let's go ahead with the problem. Assume that you are having a mass like this, which is impacting onto this particular rod or a body, let's say, and it is fixed at one end. Okay, so it travels some height h. Okay, it also deforms the rod a bit. So let's say the deformation is this much. Okay, so that means it would have caused some delta also. Okay, because of the deformation, so the mass has reached this position finally. So let's say the total work done by this mass, let's say is equal to let's say the load was P, so P into displacement, that is H plus delta. Okay, fine. So now this work done is being converted to strain energy of the rod or bar. Okay, so basically you can equate this. So what is the strain energy of the rod or the bar? It is given by sigma square into AL by 2E. Okay, so this particular work done is being converted into the strain energy of the bar. Okay, so therefore you can equate these two. So let me write it down here. P into H plus delta is this quantity. Now when you are applying the load P, there is some deformation and there is some stress caused here. Okay, therefore that stress and deformation can be related, right? So therefore you can write delta is equal to sigma by E into L. Okay, let's utilize this into here. So P into H plus sigma L by E is equal to sigma square AL by 2E. Okay, now let's simplify it. So you will get sigma into PL by E is equal to this. Let's simplify it further. So let's make the coefficient of sigma square as 1. Okay, so we have to divide this quantity throughout the equation. Therefore you will get sigma square is equal to sigma into PL by E into 2E by AL. So this is L plus P by AL. Yes. So if you rewrite this equation, you will get sigma square minus, so here you will get 2P by A. This gets cancelled into sigma minus 2P HE by AL. This is equal to 0. Okay, So you have to find what is your stress due to impact. So this is your unknown, and you can represent, so you will get a form like this, uh, plus b times sigma plus c is equal to 0, right? So now this quadratic equation you can solve using any method that you know. So when you solve this equation, finally what you're going to get is, so finally you will get an equation like this. So this you can easily arrive using the standard method, where your solution is something like this: b square minus 4ac by 2a, sort of thing. So this is very straightforward standard method to find this solution. So finally you will get this. So now you have two values here, so let's take the maximum value. Therefore your sigma maximum due to impact is this. Okay, now what is the deformation delta? So delta can be written as this into this. So finally we will get, okay, so let's utilize this functional form to derive the solution for this particular problem. So now here weight w, everything is given. Your w is the weight, so that is mass into your gravity. Okay, so 100 kg into, so your in this case the gravity is given to be 10, so 10, that is equal to 1000 Newton. Okay, so that is what it is. So the area, so your area is given to be 100 mm², so that you have to convert into meter square. Okay, so this will be square, yeah. So this is how you convert. And now your Young's modulus is given to be 100 GPa, so which again you have to convert into PA. Okay, so now this length is given to be 1 meter, so this is already in meter. And h again you have to convert into, it's like mm, so 10 into 10 raised to minus 3 meter. So you already have all these values which you have already converted. So when you solve this, when you substitute this and solve, what you are going to get is delta is equal to 1.5177 into 10 raised to minus 3 meter. Okay, so now they're asking you in mm, so you have to convert back again. So this is your final answer. So if you knew the formula, it would have been very faster to solve this. However, even if you don't know, if you know how to derive it, that will be easier. Okay, so if you want to know more about it, all these elongations and deformations, please check out the NPTEL courses. Thank you.